Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today I'm going to conduct another video tutorial on PIC18F assembly language programming. I'm basically making this video tutorial on the demand of a viewer of our channel. He sent me some real-time problem. So let me explain you the real-time problem first, and then I'm going to write down the assembly language code for PIC18F microcontroller uh, for this specific application, and then I'm gonna simulate the uh, program in the Proteus environment so that we can verify our results that it is working. Okay, first of all, let me explain you the problem. So this application utilizes PIC18F for 18F2585. So this is the very first tutorial in which I'm going to use another IC instead of 452. Usually I use PIC18F452, but in this specific application, I'm using PIC18F2585 because it was the demand of the use viewer. Then uh, we have two outputs here. RC0 pin is output 1 and RC1 pin is output 2. Okay. And then we have an input which is RC2. And basically, push button is connected to RC2. So whenever if I'm going to press the push button, so the pushed status is basically indicated that this pin will receive 1. And if button is released, then this pin will receive 0, right? So 1 or 0 is received depending upon the uh, button is basically pressed or released. Okay. So let me explain you what is going to happen when this push button is pressed. So let's say this is a push button which is connected to this pin RC2, and if I'm going to press it, it will basically make the contact. Uh, so that means it is pushed, right? So what is going to happen? This pin will receive, RC2 pin will receive 1. And what should be happening when we just press it? If the we just press this button for only brief interval of time, and when I say brief, it means time less than 2 seconds, right? So we are going to test it whether this push button was pressed for 2 seconds. If it is less than 2 seconds, okay, 2 seconds, let me write it down. If button is pressed for time duration less than 2 seconds, then or you can say button was just pushed briefly and then it was released. So what should be happening? Controller should turn on the RC1 or the output 2. But what happened if your push button was pressed? Push button is pressed and hold for at least 2 seconds. Remember the duration is here 2 seconds. Then what will happen? Turn on the output 1 or RC0 pin. So this is a real time problem. Why? Let me give you an example. Uh, Usually when we use cell phone, there is a power button. If you just press it briefly, so what will happen? It will ignite your screen of cell phone. But if you press and hold it for certain duration, as in this case, this application requires 2 seconds, then it will give you an option to turn off the power. So the same button, the same input button is basically serving for two different outputs. That is what we are trying to do in this application. So let me write the code now. I hope this explanation is clear. Uh, and what we are supposed to do using PIC18F2585. Uh, and we are using one input and two output. Okay, so I'm going to write down the code. The very first thing that we want to enter inside the code, or we want to write down in the code, is the configuration of input and output pins, right? So we have got three uh, IO pins here, two inputs and one output, as I've already explained you a bit while ago. So first thing that I want to do is basically the configuration. So For IO pin configuration, I hope you have been following my video tutorials. So you must be aware now that you need to actually set and clear uh, the corresponding pin of the trace register of port C, respectively for the inputs and outputs. So I'm going to go set bit set file. Trace C is the port C register or the control register, and I'm going to make it set. So RC0 is input, uh, sorry, RC2 is input, which is this push button, and the next thing I'm gonna do is BCF, which means I'm clearing it. Press register again. This is the file register RC0, which is the first LED or the first output. So I'm gonna mention it output 1, and then BCF press C, comma RC1, which is my second output 2. That's it. These are the lines that I have to write down for making any making any pin as an output or input. So I hope you understand it here. Let's proceed further. Okay, once you have configured IO pins, then next step in this application is to configure timer. And why we need timer? Because remember there is involvement of time delay, and whenever you want to generate certain time delay or you need something to monitor for at least some duration, like in this specific application, we are going to monitor push button if it is basically pushed for 2 seconds or not. For this purpose, we need to generate some time delay within the microcontroller so that for that time delay, it will monitor this push button. So for that time delay generation, we need to configure timer. And there are multiple timers, but I'm going to use timer 0 in this application. Timer 0 I'm going to use. And when anybody is configuring timer, he needs to define three different variable, three different registers, right? What are those registers? Timer 0 control, timer 0 H, and timer 0 L. These are three important registers in any timer if you want to configure those timers, right? What is timer 0 control? Basically, this is the most important register which actually tells you how many bit of timer you are utilizing, what is the status of the clock, what is the if this timer is going to enable on positive edge of the clock, or if it is going to enable on negative edge of the clock, or if there is any pre-scaling concept is being used or not, right? So all those decisions depends upon the value of timer 0 control. So for 2 seconds I've already calculated, assuming that I'm using 4 megahertz crystal oscillator. I'm assuming here that it is supposed to be 4 megahertz, and uh, on 4 megahertz I need to for 2 seconds delay of how many 2 seconds. So for this, the value that we have calculated is basically is 0.4 hertz, right? Similarly, timer 0 H value that I've calculated already is 85 hertz, and similarly for timer 0 lower byte, its value should be EE hertz, right? This is in hexadecimal. Again, I will repeat, I've already made so many tutorial, a complete sequence on timer configuration. So if you haven't followed those tutorial, it is highly recommended for you guys to follow that tutorial so that you can actually be aware about all the concepts which are important here, right? Furthermore, beside these uh, registers, you need to also check for a single bit, which is basically timer 0 IF bit, and timer 0 IF bit is present in the register, which is interrupt control, INTCON. So in interrupt control, there is a flag bit which is known as timer 0 IF, and what is the importance in the timer of this specific bit is basically it is going to be alarm of timer has expired, right? For example, we have started the timer, we have turned on the timer, but if it is expired, so this bit will become equals to 1. So this bit value is very important, and initially it should be equals to 0. So initially it should be what? 0. So these are the important configuration that we need to incorporate inside this code. So I'm gonna incorporate the next code here, and I'm gonna use a different color. Let's say, yeah. So what I'm gonna write, move literal to working 04 hash. This is the value that I want to feed in timer 0 control register. So next line would be what? Timer 0 control, and then move literal to working 85 hash, and it will be moved into move working to file timer 0 hash, and then move literal to working double E hash, and it will be moved in move working to file timer 0 L register, right? Next thing, we will make sure that this timer 0 IF bit is 0. So for this purpose, we can write simply BSF PCF interrupt control is the register, and the bit name is timer 0 IF. So now timer 0 IF bit is cleared, or it is equals to 0, right? So these are the lines that we need to write down in this code, and it will actually configure our timer. So these are the basic two steps that we need to follow. Next thing, now we have already configured our IO pins, we have configured our timer. Before we gonna make the decision, of course, the next step should be what? Next step, we will make a decision whether the push button is pressed or not, and if it is pressed, will it be was it pressed for more than 2 seconds or at least 2 seconds? Then we will go to output 1 and turn on the LED connected to RC0. Or if push button was simply pressed much less than 2 seconds, then we will go to output 2 and we will turn on the connected LED connected to RC1, right? So that means we have to take a decision here, and then next thing, we have to either switch in either of the two outputs. So I will make this code simple for you guys, and I will write down the codes for output 1 and output 2 first, and then we will come back to the decision making part of the code, right? So in the, let's say I'm going to write here two outputs. The first output is, uh, let's say, output 1. In this branch, what I'm going to do, I'm going to turn on the LED connected to RC0. So BSF port C comma 0. That's it. This is the output 1, right? This is the output 1. And now I will also write another output, which is uh, output 2, and in this output I am going to turn on the LED connected to RC1. So BCF or BSF port C comma 1. So these are the two possible outputs that we are going to utilize, either this output 1, which I have written down in blue code and blue color, and or either it is going to switch to output 2, which is written in the green color, right? But before we go these two output, we need to make the decision. And how you will actually make that decision, that decision will be made based upon the port configuration or the port value, right? Which port? Let me write it down for you. I'm gonna go and check this push button is pressed or not. For this purpose, I'm gonna use, let's say, I'm gonna take a decision. Let's say decision is bit test file skip if start port C comma 2. Port C means this port C, and 2 means RC2 pin, which is pin connected to push button. So I'm testing it whether this is receiving 1 or not. This S means set means 1. So I'm testing it whether this bit number 2 of port C has become 1 or not. If it is not 1, so what I will do, I will simply write branch again, or simply test it again, right? So this is the next critical step in this code, that what it is doing, let me explain it to you. It is testing port C and pin number 2, which is basically same this push button. We are basically testing it whether this push button is pushed or not. If it is not pushed, we are going to repeat this same check. We are repeating this stuff again and again. So we are doing this in infinite loop. Unless it become true, we will come out of this loop, right? So let's say the push button is pressed and we will come out of this loop. Now we have to make another decision. We have to decide push button is pressed. Okay, we are into the next part of the code, and next part says we have to decide whether the push button was pressed for 2 seconds or not, and that actually can be true with the help of the timer. First of all, you will start a timer and continuously check for this pin if this pin is still 1 or not, if this pin is still 1 or not. And if timer expires for 2 seconds, that means pin was consecutively 1 for 2 seconds. That means we need to switch to output 1. But if any of the two condition, either timer is not expired and port C goes, pin number 2 of port C goes down, that means push button has been released, so it will receive 0. So that means we need to go to output 2, right? So what I'm going to do, I'm going to write another piece of code. Let me choose a different color. Yeah, this one. So I'm going to write BSF timer 0 control register, and its bit is timer 0 on. So we are basically turning on the timer, right? So now timer is started, and now timer is started, and we will continuously check for one thing. We will check is bit test file skip if clear, is timer is still if timer 0 if bit which is present in interrupt control timer 0 if is still 0, that means timer is not expired. If timer is not expired, okay, then okay, I will write down something here for a while. I will just, if timer is still 0, then skip this line, whatever this line, I'm going to write it for a while. Okay, if timer is not expired, then I'm going to skip this line, and I'm going to check whether bit test file skip if set port C comma 2 is still 1 or not. And if it is still 1, then we're going to write something. Okay, I will be explaining you in a while. Okay, uh, so what is the next thing? We will repeat it. Branch to timer check. Let's say timer check is a variable, and that I'm gonna use here. Okay, this is the piece of code that I've written. Let me explain you first, and we will then I will put some values over here. So what I'm doing here, I'm testing whether your timer is not expired yet. If it is not, then skip. Check this line. And what is this line? We are testing if it is yet pressed or not. If it is pressed, then skip this code and go to back. So it will loop back, right? So basically we are testing two things. If timer is still on, that means 2 seconds are not passed and switch is still pressed, right? Okay, so let's say timer expired and and you are in the same loop. That means basically the push button was pressed. So timer expired. So this timer 0 if bit, let me correct it. There is a mistake. This is basically timer 0 if bit. And if timer 0 if bit, if timer is expired, so this value will become equals to what? Equals to 1. This value will become equals to 1. So this condition will false. This condition will not switch over here, rather it will execute this line. So timer is expired, that means the switch was on for 2 seconds. So what I am supposed to do, I'm actually supposed to write down here uh, branch to output 1. This is what I'm supposed to do. So if timer expires, that means I will no more check for port C2 if it is pushed or not. I will simply jump to output 1. But in case timer is not expired but port C receives 1, that means this condition is no more true. This condition is no more true. So that means timer is was still on, and somehow your push button was released before 2 seconds, that means your circuitry was your push button is released, that means you're supposed to go to output 2. So here I will write uh, what at this position I will write branch to output 2, right? So this is how this loop works, right? So I hope everybody understand here. Let me explain it to you. This is very critical to understand uh, the piece of codes. This is the very first piece of code that I have written down. Let me highlight it for you. This is the first piece of code that we will write. Okay, then this was just all about the IO board configuration. Then the next part was timer configuration, all about the registers involving timer and timer 0 IF bit for timer expiry. Then we will check whether the push button was pressed or not. Then we will start the timer and continuously check whether timer is expired or push button is released, right? In either of the case, we will go to either of the output. Either we go to output 1, in which we are turning on the bit connected or LED connected to RC0, right? So that means I can actually move this part over here. This is going to be next part. Let me, okay. And then we will actually move to output 2. So this is the output 2, and in this output we are basically turning on the LED connected to our RC1, right? So these are the two possible options that we can actually switch on. I hope this code is clear. Now I'm going to go to Proteus environment and will show you how this Proteus environment will work for this specific code. I hope this code is understood. Again, I will repeat, there are two things which I suppose you are already aware, either IO port programming and the timer 0 configuration. If any one of the viewer of this video is not aware about those concepts, you must go and watch it. I will put here a hyperlink to those videos. It's for you if you can easily watch and understand IO board configuration and timer configuration. Otherwise, the code or the piece of code is basically complete. Now I'm going to go and execute this code in MPLAB and as well as in the Proteus. So I will show you the Proteus environment. Okay, this is the Proteus simulation startup that I've actually established for the code for the application, for which code I've already explained you guys. So there are two LEDs, LED 1 and LED 2. LED 1 is basically indicating output 1 and LED 2 is indicating output 2, and this is the push button that we have been discussing. So if I'm going to press it for a short interval of time, this LED 2 should be on because it is representing the output 2, and if I'm going to press it and hold it for at least 2 seconds, then LED 1 should be on, which is output 1. Okay, this setup is right now not showing any output because Proteus is not running. So if I'm going to start the simulation, let's turn on this simulation, and now I'm going to press it and hold it for at least a while so that 2 second timer expires and LED 1 shows some output. You can see that since I've turned on this simulation, these blue colors indicating and these red colors indicating their power supplies are on. So if I'm going to press it and hold it, see, the output is there. I pressed it and hold it. Let me rerun the simulation. I'm rerunning it. Yes, it is redone now, and I'm going to press it and hold it for at least 2 seconds. Yes, you can see that. I pressed it and hold this push button and LED 1 is on. That means output 1 is switched. And if I'm going to rerun it, okay, now I'm going to press it for a very brief interval of time, much less than 2 seconds. So what should be happening? LED 2 should be on. Let's see. Yes, I hope you can see that. Let me rerun it again. So I'm just going to press it for a while. See, it's working. So I hope you have understand the complete Proteus setup and complete code of this application. This video tutorial was actually recorded on the demand of a one viewer of my channel, uh, and he wanted me to explain the complete assembly code for this press and hold application, and he wanted to perform it using PIC18F2585, and I tried to explain complete code, the requirement, and furthermore, I have shown you here the Proteus environment. I hope every point was clear. Still, if you have any query, you can post your queries in comment section. Thank you so much for listening.